skills, enabling humanoid robots to autonomously construct structures in unconstrained environments that may endanger human life.
Welcome to the Humanoid Robotics Lab. I'm Adrian Stoica, and this is Hope 2.
Hope 2 is a small humanoid which we taught to see, recognize objects, walk to them, grasp, and manipulate. The target capability demonstration is autonomous assembly of a structure from aluminum bar. This and other apparently simple practical tasks are still challenges for autonomous robots. Imagine this robot is adult-sized and it can do real-world jobs. Besides construction, it could do many other operations in dangerous environments. For example, it could search and rescue people from buildings damaged by fire or explosion. Humanoids have a key advantage. Their shape is optimal for being fostered by humans, which we believe is the key to cognitive development. In our experiments with Hope, we started by training it to keep balance. We developed a vision system that enables the robot to detect colored targets, track them with its vision, and after learning eye-hand coordination, able to grasp them. The robot can observe and imitate human movements, which may help it learn how to perform a task. The robot is able to look around, locate a bar on the floor, evaluate its position, and start walking towards it. We developed two different types of walking: a faster, reflex type walk, and a computed walk, where the position of its step is thoroughly calculated and hence slower.
Look right.
Looking right.
Look left.
Looking left.
Turn left.
Turning to the left.
Let's go to the presentation. So I'll tell you what's going on in the rest of the movie. So basically, there is a spoken interface of the robot. The robot is responding back, and basically the purpose of this kind of analogic teaching, which is taking the robot through a series of movements, is basically transferring somehow the motor skills to the robot, and then the robot is doing it autonomously. So that's the part that was done at JPL, and from now on, I put a disclaimer. All the kind of things are not endorsed by JPL, and as a matter of fact, there are a couple of ideas that are not even endorsed by myself. I just think that there are interesting things to put there and to discuss, and I find it also a little bit one of the ironical things of life that I've always been a believer in autonomy and humanoids and so on, and here I am today actually trying to convince that one of the solutions is teleoperation as opposed to autonomy for robots, but I think it has a certain rationale to it. So this is the table of contents, and this is, of course, well, this is the busiest slide, and I want to talk about healthcare teleoperation centers, and the rationale in the H+ type of a context is basically we want a mean to exceed the kind of physical limitations and maybe enable us to reach that level where different technologies will be available to us. So for example, if you need assisted living or in any way to improve quality of life, this kind of teleoperation centers, which may include robot in your homes, are something of interest. Then I want to talk about how to exceed our sensorial limitations, which are dictated by our physical limitations. So basically, how can I see anywhere in the world and actually even perhaps operate on different things on the world anytime? And that's basically I'm going to talk about telepresent mediation with humans, robots, and infrastructures. I will say a few words about robotic scaffolds, which is an idea that kind of brings together scaffolds used for tissue engineering and organ growth with robotics. So kind of looking at these systems as robots. And then I'm going to do a little bit of speculations in how to combine biological signals from multiple individuals, potentially as a means to achieve some form of collective, at least emotional intelligence, if not of different sort, and maybe how to combine this kind of signals with some from the machine. So robots for assisted living has been around for a while. One of the interesting things for elders apparently is the issue of loneliness, and even robotic companions proved to be a useful application. And robots are kind of designed to maybe bring objects to you, help you feeding an older person, carrying the person, and so on. But all of this, although there are still kind of a lot of, let's say, physical challenges and issues related to the safety of these robots when they operate next to a human, the biggest problem is still the intelligence of these robots. And I think we are still quite a bit far, just even judging by the kind of demos that we see from people, including the great press you see when a particular robot is able to go to the fridge and fetch a beer for you. That is like a big success. So, well, this is kind of a long way from having the robots assist you in your homes. And again, I do believe that the intelligence is the most important bottleneck. But one way to do that is actually replace, in those situations, the robotic intelligence with the human intelligence. So basically, okay, it's a kind of like a paradigm shift. Instead of trying right now to reach robotic intelligence and then to deploy the robots, which may take 10 years or who knows how long until we feel safe and comfortable and so on with those, maybe deploy now whatever robots best we have and teleoperate them. But in order to make it economically, we need to kind of share basically so the user must kind of operate in multiple homes. So basically this on one hand reduces the deployment time, which actually can do it now. So we could kind of control the robot around, just leave to the robot maybe a little bit of autonomy in a reactive mode. But other than that, all the intelligence says, okay, you go to the fridge, you go to do that. All this can be controlled by an operator, which can be sharing actually to do it for different homes. The robots will learn on the job. This is an important part. And then we can kind of gradually release the control to the robot autonomy. And basically this is accelerated by working in the real environment with real interactions. So this kind of an imagination of types of robots would be kind of controlled from an operation center and basically to do all the kind of feeds, all the kind of things that we're trying to do right now, but with robotic autonomy. Plus, it's actually using these types of platforms where they show let's say, the face of a person, which can impersonate perhaps a relative that you feel more comfortable to take care of you, even if it's kind of an avatar that is controlled from the operations center, or even connect different people and show on the display the face of a partner. So kind of connect it with different other people in the world for the purpose of interaction. So this idea actually of, there are a couple of ideas that were related to what we saw in some of the movies recently. In the movies like Surrogates, there was an operational or operation center or control center, but in that case, actually still each person controlled its own robot, and basically this kind of center was more like a safety or monitoring thing, while in what I'm discussing right now is actually from that center, every robot in the home is controlled. Okay, in terms of the training, again, it's an important part because we would operate this kind of robots as marionettes, and then in time we kind of cut the strings from Pinocchio and will basically acquire the autonomy. How do we control these robots? Well, joysticking is one way, programming is another way. If you look at the chart here, like degrees of freedom that you can control and ease of use, well, with the joystick, it's easy to use it, but we have few degrees of freedom. If you do the programming, you could control more degrees of freedom, but it's very bulky and it's not really easy to do the programming for moving in real time with certain situations. Researchers are looking at different alternative means, and one of them is kind of using a variety of biological signals, for example, EMG or EEG for that sort. And I have two movies that I don't think I have the time. If there is time, I'll show them at the end. But basically, some simple experiments with EEG, control of a robotic hand or a robotic arm, or EMG, basically driving a car around and so on. Keep that in mind. For the moment, let's just accept the thing that we could do at least simple commands, including with EEG, like move to the left and move to the right. So it's very simple navigation things. I'm going to get back to this one. I will jump actually back to the idea of robots that are controlled from an operation center of some sort, but basically the robots are acting as a telepresence mediation of some sort. So basically allow you to, for example, a doctor to come to a patient, or even to do some kind of a remote consultation of some sort, or even actually have the robot on the street going around and transmit the live video from that street to the people who are in the operation center. All this is nice, but actually we could do it, and probably we could do it cheaper with humans right now. And basically, this concept of a telepresence mediator, or a telemediator, I can call it, as a service, I consider it similar to a car rental service, or maybe like a limo service, because it comes with its own driver. And people will say, okay, so, well, I do have a Skype connection, and I can do a teleconference with my friend if I want to see it in Paris. Well, you can, but you don't necessarily have a friend in every place in the world, and you cannot access it at any time. So if you have a service that allows you right now to connect and do live streaming, let's say, from Rome, and move on the streets in the same way you would like, because you drive a cameraman in there and it's feeding you live video. That's kind of an interesting feature. So anyway, that's kind of this particular website that would show you a little bit more, and I won't show a video or a demo of it, but basically, again, the idea is you can have a service that you can go to and basically offer you this kind of vision any place in the world, or at least in the places where the locations are listed in here, and at the time of your choice. So this is kind of, okay, this is done with the humans, and at some point we're going to do it with the robots. But the more interesting thing is if we do it with, actually with the infrastructure itself, not necessarily having to have anything moving for that reason. Well, this is a little bit, I forgot to mention about that, but avoiding being kicked out of the family. I attended like family events in this way. I went to various things, and even if you are immobilized or some sort and you cannot travel to different places, you can still have the experience, at least the visual experience of climbing Mount Fuji, for example, because somebody is going there. It's basically the guy you rented, and he's kind of transmitting you live the images from there. So, well, this is different than TV and video recording and so on because of the liveness of it. It's personalized. It's remotely guided by the customer. And basically, you can even have the teleoperation. So going back to what I was saying, that you can have even the infrastructure do this at some remote time, well, at some time in the future. Think of, for example, this is, let's say in London. At some point a few years ago, there were about 10,000 CCTV, actually surveillance cameras, which is on top of all the other cameras that are in the stores and so on, that allow basically pretty good view on different places. So now imagine that you have a context in which you can control, or let's say you can synthesize the image as it would be seen from the middle of the road from the cameras that are around it. Okay, so you have all these kind of surveillance cameras, and right now I can reconstruct an image in here as I would be seeing it from here, but basically the image is constructed by the sensor information that I have in different surveillance cameras. Now think also that I can drive this one, perhaps even with by brain control, or clearly I can do it with EMG, and navigate it through the street and see basically through feeding from the internet cameras or for the surveillance cameras as it would be if I would be kind of walking in the street. Or if I would be like flying on the street, because you have the feeling or the perception, and you get the video feed, which is synthesized, and perhaps it will take some computational power to do that, but that is feasible. Okay, jumping to a totally different subject. So in terms of, this is an idea that relates to a combination between scaffolds for tissue engineering and robotics. Basically, scaffolds very much act as a support mechanism for the cells to differentiate and grow. Basically, these are kind of static things, and in many cases, they are perceived as something that kind of basically absorbs or dissolves. But one of the interesting observations is that, and it's kind of natural that basically mechanical tissue stimulation is beneficial. So basically applying different kind of stresses to the tissue actually favors the growth. So then the idea is, okay, well, if I make this kind of scaffolds, instead of being static, if I make them dynamic and I change them in some sort, for example, compressing on the tissue, maybe I can actually improve the growth of those tissues. So this is kind of the idea of, okay, having a flexible and configurable scaffold so that stresses the cells and stimulates them to increase the growth. On the other hand, it can also increase the size or decrease the size. And that could accommodate, for example, if you, let's say you're building a scaffold for a child and something that needs to grow quite rapidly, or for an infant, you could actually build in the mechanism that the scaffold actually expands instead of putting from the beginning the larger size, and perhaps the cells cannot get to configure to that form. So if you look at this kind of property of the scaffolds kind of to be moving, also it's important to have actually, so not only to move, but you also can release different drugs that help actually the growth. If you look at their ability to sense, because it's important to kind of determine for optimal release or for optical mechanical movement, kind of what is the status in there. So you look at them as both moving, sensing, and the fact that you need the controls for all of that. And ideally, you can map this kind of sensing to the action through some form of an algorithm. Basically, all this kind of define more or less a robot. So you can start looking at this kind of robotic scaffolds as robots that you can put, and perhaps they can even be biocompatible and biodegradable. So anyway, this is one of the speculations in here. And getting back to the biosignals. So here is an idea that, okay, from all this kind of EEG signals or EMG signals that we collect, perhaps we can kind of bring them together and obtain some form of collective emotional intelligence. It's clearly that we can detect at least emotions with EEG. And what if I fuse this kind of features or emotions from different people together and I can aggregate to somehow? Is that an indication of a collective emotional intelligence? Clearly, at least in the realm of control, I can actually have and do a shared control. For example, if certain biosignals are used for controlling different degrees of freedom. So for example, we've been doing some experiments in that sense. One of the users is kind of thinking of moving the robot left to right. Another user is controlling kind of moving up or down if it's a helicopter of some sort. So actually they can kind of share the control that is coming through these biological signals. But that in the control part is actually very simple and straightforward, especially if you separate the degrees of freedom in control. But it's more interesting is becoming in the moment when you're talking about how to make a joint decision or a joint assessment of a complex situation. Think of we saw yesterday also the 6 blind people and the elephant. So somebody has a perception and it feels like the elephant looks like a wall, it looks like a tree, and so on. But when you try to bring this together, perhaps you can aggregate the information from the biosignals in such a way that you can reconstruct actually the picture of the elephant. In terms of this kind of collective decision making, there are many situations when you may need to make a decision in very short time where a binary voting type of system is non-optimal. So it's just a yes or no, because many times you actually have an analog kind of value that describes the situation better. Maybe you are like 51, 49. Okay, 5 minutes? Oh, right. Okay, well, yes. So this is about multi-brain. And perhaps you can actually combine the features. So you could do it either at the signal level or at the feature level or at a different level, but actually you can combine these things that come from a human with some form of a signal that is coming from a robot. Okay, I may jump over the security, but perhaps 1 minute I'll go through it. There are different ways that the systems are attacked, and robots actually introduce some new types of threats. One of them is the fact that actually they can move around the house and they can do things that if a hacker takes control over them, maybe it's not as simple as having your computer or whatever, which you always can kind of shut off, especially if the robot is running around faster than you. You know, this could be disabled, taken control, and people have looked at this in different papers, even in the toy robots, what can be done in terms of hacking. And for example, part of the threat comes from the fact that the encryption is not necessarily always provided. You cannot afford to put a very complex encryption in a $40 robot or so on. So for that reason, there are a couple of vulnerabilities which more or less, conclusion from that paper, someone might be able to drive your robot around, look around your house, listen to your conversation, and so on. It's actually even more scary if it's looking to obtain some personal information in the context of wireless implants. And I won't tell more about that right now, lacking time. But some people are actually concerned of the robot criminals, part humans, part robots. And actually we see a trend. Basically we see it in the prosthetic devices, which again are making us maybe closer to the robots in some extent. And on the other hand, at least in the humanoid point of view, the robots are coming closer, which basically leads, I think, right now to a certain convergence in that, perhaps in the context of cyborgs. But perhaps at some point there will be a diversification of this. And that diversity, well, on one hand, it's related to this kind of transhumanism, and in the other, for all other practical reasons, you could have more colorful diversity, I guess, in the future. And well, since a few minutes are finished, basically, yes, I do believe that the society will have actually more diversity after we are converging. Probably this is going to be in waves, so we'll converge and we'll diverge a few times. And since this concern has been expressed a few times, I guess I'll leave this one, which was an attempt at some point a few years ago to some Korean type of a poetry, but more or less, well, you can read it. Thank you.